Hello everyone, welcome to my another video. So in this video I'm going to cover creating a shared folder on a Fedora Linux virtual machine here in VMware and mapping it as a network drive over a physical Windows PC, and the connection is going to use SMB server, which is server message block protocol, through Samba software installed on Linux, right? So before we jump in, let me quickly explain what Samba actually is and why it matters in this particular task. So imagine Windows and Linux are two people sitting in the same office. They both want to share files with each other, but there is a problem, right? Windows speak one language called SMB, server message block, and Linux natively doesn't understand that language at all. So what do? You hire a translator. The translator is Samba, right? Samba is a software that runs on Linux and translates everything into SMB, server message block, so Windows can understand it perfectly. From Windows perspective, it looks exactly like talking to another Windows machine. It has no idea it's actually talking to Linux. Now, SMB itself, server message block, is simply the protocol, a set of rules that Windows has been using since 1980s to share files and printers across a network. Every time you map a network drive in Windows, every time you access a shared folder, you are using SMB under the hood. Port 445 is the main port it runs on. Now, in real life, where do you see this? Every company that has a file server, whether it's a shared drive, a network drive, or a department folder, is running SMB. So when your IT team set up a drive that everyone maps as Z or S drive on their laptops, that's SMB. If that file server runs Linux, which many do because Linux is cheaper and more stable, it's running Samba behind the scenes. So what we are building today is exactly that, a real working file server, you guys. So first of all, what we're gonna do, we have two machines. Basically at this point, two machines. Let's think of it this as one Linux particular machine, so Fedora Linux VM, which will act as our file server, and a Windows PC, which is Windows PC, basically my own physical PC, which will be working as a client. Of course, we will install Samba on Fedora, create shared folder, configure the Samba file, the config file of Samba, handle the firewall, SELinux, security layers, and then from Windows we will map it as a shared folder. So we will install and do those things. Let's get into it right away. Let's go. Okay. Let me type my password. Okay, so let me open the terminal. There you go. So who am I? I am Kamal Gurung. What's my hostname for Fedora? Right, and let me IP address. So it should be bridged, right? First of all, let me check that. We want that to be in the same um, network. Oh my God. Oh, yeah, bridge, of course. So 237 CLS ipconfig 224 237 24 24. We are good, right? So let me install Samba right away. Sudo dnf install Samba common -y password, because it's sudo, right? So here we are installing two packages at the same time. Samba is the main file sharing daemon, the actual service that runs in the background. Samba common provides shared configuration files and utilities that both server and client side need. And the -y, this is yes automatically to all the prompts. We don't need to keep confirming. Sorry. Perfect. So we are installing. Okay. Just give it time. I'll come back. Perfect. So Samba is complete. I mean, installed completely. Now we are going to create the shared folder. Let me enlarge this a little bit so that it'll be easier. Let me clear a little bigger. Why not? Sudo mkdir -p. So we're going to create the shared folder right here in this path. MBA shared Samba chmod 777 srv Samba shared. Oh wait, sudo. Who said Samba? There you go. So now we create the actual folder that we are going to share. I'm putting it as srv Samba shared. This is the standard location for Samba shares on Linux. Think of it as the physical folder sitting on the server that everyone will access. And ch777 gives full read, write, and execute permission to everyone, which is fine for a lab environment. So in a production, you don't give this all read, write, and execute permission to everyone, right? So before that, I think we know what this 77 is about. So let me show you one thing. So if you see here this first line here, so this shows if it's D, it's a directory, right? It's a directory. If the blue color comes and D is here, you're gonna see it's a directory, which is basically folder in the Windows. And this first RWX read write execute, that's the um, permission that is allowed for a owner. And this second one, which is RWX, there's no W, means there is no write permission for the group. So second one is for group, and the third one is for the others, right? So and the value for this RWX is 7. Like R gives 4, W is 2, and X is 1. So if you add 4 plus 2 plus 1, it's basically 7. So here you are providing 7. 7 means you are giving read, write, and execute permission to everyone, basically, not only the owner but also the group and the other users. So that's the bottom line. So if, like, for example, create a file, right? So just create a file, test.txt. If you see here, so this has read write by default, only read write, right? But if you want to give all the permission, so just give 777 test.txt. Now if you see, it gets all the permission, right? From RW, it became RWX, RWX, RWX. Now if you want to give just, you created it, you're the owner, you want to have S7, of course, and then you want to get just 5. What is 5, right? 4 plus 1 is 5, of course. So read and execute only. So that's how you give the permission. You see, read and execute, read and execute. So that's what it is. So let's get back to our thing. So we're gonna create Samba user now. Let's clear this screen. Sudo user add -m -s s not s bin, no login, Samba user. Just give me Samba user for now. Sudo smb psswd -a Samba user. Let's just skip that, our regular Apple 123. Okay, mismatch, my bad. Apple 123, Apple 123. Okay, added users. Let's enable that as well. So we enabled, right? So we did everything. So now here is something important to understand. One concept, we have a user like Kamal Gurung, right? Its own, but that's for Linux. For Samba, its own completely separate password database from Linux. It uses like that. So even if a user exists in Linux, you still have to register them separately with Samba using sub password. The user add command creates the user. The -m flag means don't create a home directory. This user doesn't need one, right? The -s has been no login means this user cannot SSH. Just give me one sec. Okay, sorry about that. So the -s has been no login means this user cannot SSH into the machine or log in directly. It exists purely for Samba file sharing access. That's security based practice. And the SMB password -a adds them into Samba's database, and E enables the account. Set a password you remember, and I'm using Apple 123, just best practice. So now we have to configure the configuration file here. Sudo vi etc samba smb.conf. Okay, here we have to go all the way. Sorry, what happened here? Down, go to the end, and add these things here. Share drive, path equals to srv samba samba browse equal to yes, right table equal to yes, valid users equals to Samba user, create max equals to 0664. Let's just do this first and we'll talk about it. Directory mask equals to 0775. Let's save it. So let me explain each line. Okay, so for that, let me just see that file. Okay, so let's see here, right? So the name in the brackets, shared drive, is the share name. This is literally what Windows will see when you type the network path. Path tells Samba which folder on Linux to expose. And browsable yes means that share shows up when you browse the network. You don't have to know the exact name. Writable yes means user can create and edit files, not just read. Valid users restricts access to only Samba users. Anyone else get access denied immediately. Create mask and direct to max control what permission new files and folders get when created through the share. Right now we save this. Let's just go here. Now we have to, let me just test. Server role standalone, load service. Okay, so this is good, right? So before starting the service, we always run test PAM first. This reads the SMB file, right? And checks for the syntax errors or typos. If it says loaded service file, okay, which it did, I guess. Loaded file service file, okay. We are good. If it finds an error, it tells you exactly which line and what's wrong. So always run this before starting Samba. Saves a lot of troubleshooting time. Now we start the Samba service. Systemctl enable. Spelling is the now SMB and MB. Created sudo system status SMB. So it's good. It's actively running. So okay, sorry about that. So it's actively running, right? So we are good here. So, oh, the other thing, last part is missing. So we're gonna do that as well. Firewall and SELinux thing. Let me do firewall, sudo firewall, cmd, permanent, and service. Sorry, let's see this. Samba perma and okay, success. Let's reload and check. Okay, we have Samba, right? So we are good. Now the another thing we're gonna do is, so what did we do here? I'll explain. Even on a local network, Fedora's firewall called Firewall D runs on the machine itself and blocks incoming connection by default. This is separate from your home router firewall. So we need to explicitly tell it, to allow Samba traffic through. The permanent flag makes it rule survive reboots. You should now see Samba in the list, which we did. Now the last part is something that catches almost everyone. That's SELinux. So SELinux, which is also known as Security Enhanced Linux, it's a second independent security layer built into the Linux kernel, right? So before explanation, let me just do this command. Samba, sorry, export all rw1 sudo chmon -rt samba crt service. Okay, cannot access. Are you kidding me? Sudo t samba cannot access shared. Can I see it's gone cannot access. Okay, just hang on 1 second. Let me check. Okay, the silliest mistake ever. The spelling was mistake. So instead of Samba, I was just keeping hitting Samba, and I was checking if I already gave that 7.7 permission, but no. Um, so this is the thing, spelling mistake. But anyway, so we did that right. So what we did here is SELinux Security Linux. Again, I said it's a second independent security layer. Think of it this way. Normal file permission, the CS mode 77, are like a key card system at a building door, right? If your card is authorized, you get in. SELinux is like a second security guard standing inside the room. Even if your key card worked at the door, the guard gonna check your ID again and ask, are you specifically authorized to be in the room doing this job? So in Samba's case, even if CSmart says folder is open, SELinux asks, is the Samba process specifically allowed to touch the files in this folder? And without these commands, the answer is no. And SELinux denies access completely silently. No error message, that's why people get confused. Samba appears to be running fine, but Windows still get access denied. This sets bool command updates the SELinux policy to allow Samba read and write access. The chmon command labels our folder with the Samba shared t context, so SELinux recognizes it as a legitimate Samba share. Now in Linux we are done. The final part, we have to map it from the Windows. Now let's open the folder. Sorry, I was checking the video. So let's map a network drive, right? So it's going to be G, and the UNC path will be 192.168. So before that, let me ping that thing. Ping 192.168.1 dot 237. Okay, good. We are getting the reply. Oh, it's 237 only. Oh, that's great. Did I type that? Okay, it was Samba user Apple 123. Boom, you guys. Do you see this? Z drive is now mapped and pointing directly into our Fedora Linux folder. Right, so let me test it, like create a new file here. Testing Samba. So you create here, now go back to Linux. Where is that path again? Oh, man. So you see here, there's a file. If you want to see the detail. Okay, so Samba user created this file. Now if you delete this also, sorry, rm, let's rm, okay, let's go here, home, rm testing Samba, remove write protected. Yes, so it's deleted here, and same way it's deleted here, right? So what does it prove? That it's read write execute is going on from both way. So there, it's on the Linux side, the file created in the Linux, I mean in the Windows, and then the what we did, we accessed through the Linux, we removed the file in the Linux, and you see the result in Windows as well, right? So to recap what we did today, we installed Samba on Fedora Linux, created a shared folder, configured the configuration file, defined the shared register and everything, and okay, hang on. So the key concepts to remember: SMB is a protocol. Samba is the Linux software that speaks it. Firewall and SELinux are two independent security layers you must configure on Fedora, and two permission layers: shared label and file system label. Both must allow access to the connection to work. If this helped you, please let me know. If you have any questions, let me know. Write in the comments, and thanks for watching, and I will try to help you as much as possible. I'm sorry about distraction throughout the video because I'm trying to get a I don't have time to make this video, and then if I have time to create, I get bombarded with a lot of calls and messages, and I have to pick up those. So yeah, thanks for watching.